Okay, in this example, we have a truck that's coming down an incline. Let's treat the truck like a dot. And it's coming down an incline that's about 6 degrees. Okay, and what happens is we know that the mass of the truck is about 15,800 kgs. And we know that the initial velocity when it's up there is 12 meters per second. And when it comes to the bottom, it's about 29 meters per second. We also know that the driver has some sort of altimeter, so he can measure the altitude. So it's 1630 when he's right at the top, and 1440 meters when he's down the incline. Okay, so the question asks for gravitational potential energy. So let's just look just at the potential energy. So potential energy at the final minus potential energy at the beginning. That would give me mgh final minus mgh initial. And what we have here is mg. So h final is at the bottom where it's 1440 meters high, while initial is actually at 1630. And what you get is mg minus 190. Okay, the negative actually denotes that energy has been lost. So this is equals to negative 29 449 620 joules. Okay, there's another way you can see potential energy by using an origin to reference a level. So here we actually reference, initially we reference to Earth as 0. When Earth is at level that's 0. But let's say if I put origin right at the top. Okay, let's say origin is at his initial position. So if I were to look at PE final minus PE initial, I would actually get mg. So the final is lower than the origin. It's actually at negative 190 meters below the origin, minus mg 0, because initially we set the origin at the beginning as 0. So what happens is we have mg minus 190, which would give us the same value as negative 29 megajoules. Okay, now let's look at kinetic energy. So kinetic energy final minus kinetic energy initial. So that gives us half mv final squared minus half mv initial squared, and that gives us about half m. So v final squared is 29 squared minus v initial squared, 12 squared. And we have here, if we were to calculate out, we actually get 5506,300 joules. So it's about 5.5 megajoules. So the question asks, is the total mechanical energy of the system conserved? So by value alone, we can see that the values are different. So you would think of the change in potential energy would actually contribute to the increase in kinetic energy. So in this case, we know that it's not conserved based on the values. I can actually go based on formula wise. So if I put kinetic, so let's say if I'm looking at total energy before and total energy after. So total energy before equals to total energy after E final. So I actually get P E initial minus potential energy final equals to kinetic energy final minus kinetic energy initial. So based on this equation alone, you can see that if it's an ideal situation, by right the total change in potential energy would contribute to the increase in the kinetic energy. But in this case that we've calculated out, it does not show that. So therefore, the total mechanical energy of the system is not conserved.